Okay, so let's go ahead and take a look at this section. So this section is all about, everything that relates to factoring. And so when I look at this, my first question, the first thing that I will always do when I factor is I want to pull out a greatest common factor if I have one. So I have a 15, that's a factor. I have an x and I have a y. So then what am I left with? I'm left with a 2x squared, a minus 3xy, and a plus 9y squared. Then I look inside the parentheses and I look to see if I can factor that. If I cannot factor it, then that is my solution. Okay. I need you guys to be able to factor really, really fast. So the faster you guys can do this with also being accurate, the better off you guys are going to be. Okay, so don't take a lot of time factoring. I don't need to see a lot of steps. I do just want you guys to be able to factor, accurately and efficiently. Okay, so I know that, sometimes people put the middle number, the 5, on the top, and sometimes people put it on the bottom. It doesn't actually make any difference where you put it. And to be honest with you, you actually don't even need it at all, as long as you understood what you were doing. Okay, so let's just say I didn't do this x, because I know you guys have seen the x before, right? So what I want is I want two numbers that add to give me 5 and multiply to give me negative 24. So, and I didn't even draw a box at all, but I'm thinking, okay, factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Well, what adds to give me 5 could be a positive 8 and a negative 3. So that I have a 6x squared minus 3x plus 8x minus 4. And then what I'm going to do is I'm going to do factor by grouping. So I have a common 3x in there. I'm left with a 2x minus 1. I have a common 4 in there, and I'm left with a 2x minus 1. Then I can factor by grouping one more time, pull a 2x minus 1 out, and I am left with a 3x plus 4. Okay, we do the factor by grouping way at our school, but in the end, there are many ways to factor. I don't care how you guys factor, as long as you can factor quickly and efficiently and accurately. Okay, so whatever way is fastest for you that gives you the right answer, go with it. Okay, so question 5 is a difference of squares. 196 is a perfect square. So I take the square root of 25 and I get 5. And I take the square root of 196 and I get 14. So then I get a negative 14 and a positive 14, and that factors my difference of squares. Is the difference of squares because there's no b term in the middle? And that's why it factors to just perfect squares on the outsides? Okay, looking at 7. Again, I want two numbers that add to give me negative 19, that multiply to give me negative 66. And so again, I am finding factors here. So then 1 and 66, we don't care. 2 and 33, 3 and 22. Oh, look, I could stop. If I have a negative 22 and a positive 3, that would work. So 6n squared plus 3n minus 22n minus 11. Factor by grouping again. So I get 3n on the outside, 2n plus 1, and then a minus 2, and no, minus 11, just kidding. Minus 11, and I get a 2n plus 1 on the inside. So then this factors to a 2n plus 1 and a 3n minus 11. Okay. All right, moving right along. Interesting. This looks like a lot of perfect squares. So the first thing I would do is, instead of finding factors of whatever 25 times 16 is I would have just checked. Because this is a perfect square and this is a perfect square. I would have just checked to see. Now, everybody's positive on the inside. So I would have put a positive. If I would have had a negative here, I would have made these both negative. Okay, so my perfect square for 225 is 15. and that's a y. And then my perfect square for 16 is 4. So that I look, and then what I would do here is to see if it's actually right, is I would check the insides here. And what you get is 60y and 60y, which is the same thing as 120y. So this is 15x plus 4, the quantity squared. So it is a perfect square. Okay. Then we got to do sum and difference of cubes. So remember, if I have x cubed plus y cubed, this is x plus y, x squared minus xy plus y squared. And then if I have x, oops, not squared, cubed minus y cubed, then this is x minus y, x squared plus xy plus y squared. And that's the formula for factoring perfect cubes. So 216 is 6 cubed. So then x cubed plus 216, oops, factors to x plus 6, x squared minus 6x, and then plus 36. Okay? All right, we have more factoring. There's a lot of factoring in this. Moving right along to question 13, which is where we're going to need this -1. So this 64 is 4 cubed. This is 5 cubed. So this factors to 4x minus 5. And then a 4x, the quantity squared, plus 4x times 5 plus 5 squared. So then I get 4x minus 5, 16x squared plus 20x plus 25. Okay? And then now gets the weird factoring. And to be honest with you, I'm not quite sure if you've seen this before. So we'll go through a couple of these questions. I know we did it in notes, but again, you might still be struggling a little bit with this. Okay, so when we factor with fractional exponents, we pick out the most negative exponent or the smallest exponent that we have. And that's what we factor out. So we're going to factor out this -2/3. Okay, so the way we do that is we go through and it's like we're dividing. So it's like we're taking each term and dividing by x minus 1 to the -2/3 power. And what happens is the first one, so I'm going to pull out my x minus 1 to the -2/3. What I'm left with is these two cancel out, and I'm just left with a 4x. Now here, what ends up happening is I have a 3. I bring my exponent to the top, and I subtract. So this is an x minus 1 to the 1/3 minus a -2/3. Okay. That makes a positive. So two negatives make a positive. So really what I have is x minus 1 and the -2/3. And I have 4x plus 3, x minus 1 to the 3/3, which is just x minus 1 to the first power. So I get x minus 1 to the -2/3. I have my 4x plus 3 times x minus 1. And then now I can simplify by distributing my 3. So I have x minus 1 to the -2/3. I have 4x plus 3x minus 3. So I have x minus 1 to the -2/3 power. And I have 7x minus 3. And that's how I factor these weird fractional exponent ones. Okay, let's do a couple more. So again, the smallest exponent would have been my 1/3 power here. So I'm going to factor 10t plus 3 to the 1/3 out. And then again, I'm subtracting exponents, or I'm just, dividing. So I have 10t plus 3 to the 1/3. Okay, so I'm left with a 3t here. And then when I subtract, I have my 7. When I subtract my exponents here, I'm left with a 10t plus 3 to the 3/3 power. which is the same thing as 10t plus 3 to the first power. So I have 10t plus 3 to the 1/3, and then I have 3t plus 7 times 10t plus 3. And then I can just distribute. So I get 10t plus 3 to the 1/3 power, 3t plus 70t plus 21. So then I end up with 10t plus 3 to the 1/3 power and 73t plus 21. Okay. 19, again, smallest exponent is to the 1/5 power. So I have 3y minus 13 to the 1/5 power. I'm left with a 9y minus 2 times 3y minus 13 to the 5/5 power. Because again, I took 3t minus 13 to the 1/5 power, and I divided it. Factoring is like dividing. Okay. So 3y minus 13. You guys are starting to get to used to what we're doing. So I don't care if you skip a few steps, because again, this is factoring. And so I do actually want you guys to get this pretty quickly. Okay, so 6y plus 26. So 3y minus 13 to the 1/5 power. I'm left with a 3y plus 26 on the inside. Okay. All right. Now, switching gears a little bit, I want to find f of 2. And I want to show you guys that I can use, if I want to find f of 2, I can use synthetic division. There's an x to the 4th. There's no x cubed. There's a 9x squared. There's not an x, and then there's a 14. And then what I do is this down here, my remainder is what f of 2 is. So I bring down the 1. This is 2, 2, 4, negative 5, negative 10, negative 10, negative 20. So then that gives me negative 6. So f of 2 is equal to negative 6. And that is a lot faster than taking 2 to the 4th and then also squaring the 2 and multiplying by negative 9. Okay. Factor theorem to find all the zeros. So that's number 23. So I'm going to take my x plus 2, and I'm essentially setting it equal to 0. And then I'm going to divide. And this is like a little baby step. I gave you what one of the factors are. This is a baby step to the rational root theorem. Okay. So bring down the 2, negative 4, negative 1, 2, 3, negative 6, and 0. So you have to get 0 here, otherwise it's not a factor. So what I'm left with is an x plus 2 and a 2x squared minus x, and then plus 3. Now, this here does not factor, so I'd have to use, to find all the zeros, I'd have to use the quadratic formula. So x equals negative a negative 1 plus or minus the square root of negative 1 squared minus 4 times a times c all over 2a. So then x is equal to 1 plus or minus the square root of negative 23 over 4. And there's no more real zeros, so really the only zero that I have that's real is negative 2. Okay, because this actually simplifies to 1 plus or minus I root 23 over 4. Okay, so the only real zero here is negative 2. Okay. So now that was the baby step to actually finding all the zeros of the function. And so that's where we're at here with number 25. We're going to use the rational root theorem. And so it's factors of the first term, the last term, factors of the last term divided by the factors of the first term. So I'm going to get plus or minus 24, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8. I think that's all of them. Oh, plus or minus 12. And you have to test all of them to see which one gives you 0 for the remainder, to take this down from a cube to a squared, so then that way you can factor it. Now, like, let's just say we tried 1, right? So then that would be 1, negative 3, negative 10, 24. Bring down the 1, 1, 1, negative 2, negative 2, negative 12, and I get 12 here. So 1 is not a possible root, okay? I will show you what the actual possible root is. So let's do a little magic, bibbidi bobbidi boo. And I have 2, so I have 1, negative 3, negative 10, and 24. Bring down the 1, 1, this is 2, negative 1, negative 2, negative 12, negative 24, 0. So I have x minus 2 as a factor. I have an x squared minus x minus 12, and this is equal to 0, which this factors, so this factors to an x minus 2, x minus 4, x plus 3, equal to 0. So what are my zeros? Negative 3, 2, and 4. Okay. All right, and that is it for all the odd numbered questions for this section.